Introduction to C language. Learning objectives. In this chapter, the user would learn the following in detail: character set, variables and identifiers, built-in data types, variable definition, compilation, arithmetic operators and expressions, constants and literals, simple assignment statement, basic input-output statements, simple C programs. History of C. C was invented and first implemented by Dennis Ritchie on DEC PDP-11 that used the Unix operating system. C is the result of a development process that started with an older language called BCPL. BCPL was developed by Martin Richards and it influenced a language called B, which was invented by Ken Thompson. B led to development of C in the 1970s. To alter this situation, ANSI established a committee in the beginning of 1983 to create a standard for C, which was implemented in 1987. ASCII code. ASCII is an acronym for the American Standard Code for Information Interchange. ASCII is a code for representing English characters as numbers, with each letter assigned a number from 0 to 127. For example, the ASCII code for uppercase M is 77. Most computers use ASCII codes to represent text, which makes it possible to transfer data from one computer to another. Text files stored in ASCII format are sometimes called ASCII files. Text editors and word processors are usually capable of storing data in ASCII format, although ASCII format is not always the default storage format. Most data files, particularly if they contain numeric data, are not stored in ASCII format. Executable programs are never stored in ASCII format. The standard ASCII character set uses just 7 bits for each character. There are several larger character sets that use 8 bits, which gives them 128 additional characters. The extra characters are used to represent non-English characters, graphic symbols, and mathematical symbols. What is a character set? A character set is the mapping of characters to binary values. In 8-bit character sets, the values range from 0 to 255 and one character will be mapped to each of these values. This means that if the user's terminal is set to support a particular character set, every time he presses a certain key or a combination of keys, a corresponding character will be invoked. ASCII character set. ASCII character table shown here. C character set. These are the characters that C recognizes. Letters, uppercase and lowercase, A, B, C, D, E, capital and so on, A, B, C, D, E, small and so on. Digits, 0, 1, 2, 3 and so on. Special characters, punctuation, etc. Space, also known as blank. Variables and identifiers. Variables. A variable is a named data storage location in user computer's memory. By using a variable's name in the program, the users are, in effect, referring to the data stored there. For example, age is equal to 10 implies that age hold the value 10. Age is equal to 20 now implies that age hold the value 20. So from the above example, age changed its value from 10 to 20. Hence, age can be referred to as a variable. Identifier. In C, the names that are used to reference variables, functions, labels, and various other user-defined objects are called identifiers. The length of an identifier in C can vary from 1 to several characters. In most cases, the first character must be a letter or an underscore, and subsequent characters can be a letter, number, or an underscore. Identifiers are used extensively in virtually all information processing systems. Naming entities makes it possible to refer to them, which is essential for any kind of symbolic processing. Variable names. To use variables in the user C program, he must know how to create variable names. In C, variable names must adhere to the following rules. The name can contain letters, digits, and the underscore character. The first character of the name must be a letter. The underscore is also a legal first character, but its use is not recommended. Case matters, that is, upper and lower case letters. Thus, the names count and count refer to two different variables. C keywords can't be used as variable names. A keyword is a word that is a part of the C language. Variable name legality. The following list contains some examples of legal and illegal C variable names. Using an underscore to separate words in a variable name makes it easy to interpret. The second style is called camel notation. Instead of using spaces, the first letter of each word is capitalized. Instead of interest-rate, the variable would be named interest rate. Camel notation is gaining popularity because it's easier to type a capital letter than an underscore. We use the underscore because it's easier for most people to read. User should decide which style he wants to adopt. Built-in data types. Data type. Two types of built-in data types. Fundamental data types. Integer, character, double, float, void, pointer. Derived data types. Array, string, structure. It is a way of representing data storage formats. There are 5 basic data types in C. Those are CHAR for character, INT for integer, float for floating point, double precision floating point, and void. Values of type CHAR are, in theory, restricted to the defined ASCII characters. The range of types float and double is usually given in digits of precision. The magnitude of type float and double depend upon the method used to represent the floating point numbers. Type void is used to explicitly declare a function as returning no value. Fundamental data types. Void, used to denote the type with no values. Void cannot be used to define a variable. Void in C is a type that has no size. Thus, if one was to declare a variable of type void, the compiler would not know how much memory to allocate for it. Therefore, void cannot be used to define a variable. INT, used to denote an integer type. CHAR, used to denote a character type. Float, double, used to denote a floating point type. INT asterisk, float asterisk, CHAR asterisk, used to denote a pointer type, which is a memory address type. Derived data types. Array, a finite sequence or table of variables of the same data type. String, an array of character variables. Structure, a collection of related variables of the same and / or different data types. The structure is called a record and the variables in the record are called members or fields. Numeric data types. C provides several different types of numeric variables. The users need different types of variables because different numeric values have varying memory storage requirements and differ in the ease with which certain mathematical operations can be performed on them. Small integers, for example, 1, 199 and 8 require less memory to store and the user computer can perform mathematical operations, addition, multiplication and so on with such numbers very quickly. In contrast, large integers and floating point values 1,23,000 or 0.0000087126 for example require more storage space and more time for mathematical operations. By using the appropriate variable types, the users ensure that the program runs as efficiently as possible. List are the numeric data types in C. Variable definition. A variable is a way of referring to a memory location used in a computer program. This memory location holds values, perhaps numbers or text or more complicated types of data like a payroll record. Variable declarations. Before the users can use a variable in a C program, it must be declared. A variable declaration tells the compiler the name and type of a variable and optionally initializes the variable to a specific value. If the program attempts to use a variable that hasn't been declared, the compiler generates an error message. Type name var name. Type name specifies the variable type and must be one of the keywords. Variable declarations. From the declarations, var name is the variable name, which must follow the rules mentioned earlier. User can declare multiple variables of the same type on one line by separating the variable names with commas, colon. Character variables. A character is a single letter, numeral, punctuation mark, or other such symbol. A string is any sequence of characters. Strings are used to hold text data, which is comprised of letters, numerals, punctuation marks, and other symbols. Using character variables like other variable, the users must declare chars before using them, and he can initialize them at the time of declaration. Integer, float, and double declarations. To declare a variable as an integer, a float is a single precision floating point value. To declare a variable as float, a double is a double precision floating point value. To declare a variable as a double, expressions and operators. The symbols which are used to perform logical and mathematical operations in a C program are called C operators. These C operators join individual constants and variables to form expressions. Operators, functions, constants, and variables are combined together to form expressions. Consider the expression a plus b into 5, where plus, asterisk are operators, a, b are variables, 5 is constant, and a plus b into 5 is an expression. Types of C operators. C language offers many types of operators. They are arithmetic operators, assignment operators, relational operators, logical operators, bitwise operators, conditional operators or ternary operators, increment and decrement operators, special operators. Arithmetic operators in C. C arithmetic operators are used to perform mathematical calculations like addition, subtraction, multiplication, division, and modulus in C programs. Example program for C arithmetic operators. In this example program, two values 40 and 20 are used to perform arithmetic operations such as addition, subtraction, multiplication, division, modulus, and output is displayed for each operation. Output. Addition of AB is 60, subtraction of AB is 20, multiplication of AB is 800, division of AB is 2, modulus of AB is 0. Assignment operators. In C programs, values for the variables are assigned using assignment operators. For example, if the value 10 is to be assigned for the variable sum, it can be assigned as open quotes sum is equal to 10 semicolon close quotes. Other assignment operators in C language. Example program for C assignment operators. In this program, values from 0 to 9 are summed up and total 45 is displayed as output. Assignment operators such as open quotes is equal to close quotes and open quotes plus is equal to close quotes are used in this program to assign the values and to sum up the values. Output. Total is equal to 45. Relational operators. Relational operators are used to find the relation between two variables, that is, to compare the values of two variables in a C program. Example program for relational operators in C. In this program, relational operator open bracket is equal to close bracket is used to compare two values whether they are equal or not. If both values are equal, output is displayed as open quotes values are not equal close quotes. Note: colon double equal sign open bracket is equal to close bracket should be used to compare two values. We should not use single equal sign, just one equal to. Output. M and N are not equal. Logical operators. These operators are used to perform logical operations on the given expressions. There are three logical operators in C language. They are logical and, logical or, and logical not. Example program for logical operators in C. In this program, operators open bracket and or not are used to perform logical operations on the given expression. Logical and operator. Open quotes, if clause, close quotes becomes true only when both conditions, that is, m is greater than n and m not equal to 0 is true, else it becomes false. Logical or operator. If clause becomes true when any one of the condition where O is greater than P or P not equal to 20 is true. It becomes false when none of the condition is true. Logical not operator. It is used to reverse the state of the operand. If the conditions m is greater than n and m not equal to 0 is true, 1 is returned. This value is inverted by open quotes logical not close quotes operator. So, open quotes logical not open bracket m is greater than n and m not equal to 0 close bracket close quote returns false open bracket 0 close bracket. Bitwise operators. These operators are used to perform bit operations. Decimal values are converted into binary values, which are the sequence of bits, and bitwise operators work on these bits. Bitwise operators in C language are AND, bitwise AND, bitwise OR, bitwise NOT, XOR, left shift and right shift. Consider x is equal to 40 and y is equal to 80. Binary form of these values, all bitwise operations for x and y. Note, bitwise NOT. Value of 40 in binary is as shown above, so all zeros are converted into ones in bitwise NOT operation. Bitwise left shift and right shift. In left shift operation, open quotes x, left shift 1, close quotes, comma 1 means that the bits will be left shifted by one place. If we use it as open quotes x, left shift 2, close quotes, then it means that the bits will be left shifted by 2 places. Example program for bitwise operators in C. In this example program, bitwise operations are performed as shown above and output is displayed in decimal format. Output and underscore OPR value is equal to 0, OR underscore OPR value is equal to 120, NOT underscore OPR value is equal to 41, XOR underscore OPR value is equal to 120, left underscore shift value is equal to 80, right underscore shift value is equal to 20. Conditional or ternary operators. Conditional operators return one value if condition is true and returns another value if condition is false. This operator is also called as ternary operator. In above example, if a is greater than 100, 0 is returned else 1 is returned. This is equal to if-else conditional statements. Example program for conditional/ternary operators in C. Output, x value is 1, y value is 2. Increment or decrement operators. Increment operators are used to increase the value of the variable by 1 and decrement operators are used to decrease the value of the variable by 1 in C programs. Example program for increment operators in C. In this program, value of I is incremented 1 by 1 from 1 up to 9 using open quotes I++ close quotes operator and output is displayed as open quotes 1, 2, 3, 4, 5, 6, 7, 8, 9 close quotes. Example for increment operators. Output 1, 2, 3, 4, 5, 6, 7, 8, 9. Example program for decrement operators in C. In this program, value of I is decremented 1 by 1 from 20 up to 11 using open quote I minus close quote operator and output is displayed as 20, 19, 18, 17, 16, 15, 14, 13, 12, 11. Example for decrement operators. Output 20, 19, 18, 17, 16, 15, 14, 13, 12, 11. Special operators in C. Some of the special operators that C language offers. Example program for AND asterisk operators in C. In this program, AND symbol is used to get the address of the variable and asterisk symbol is used to get the value of the variable that the pointer is pointing to. Please refer C pointer topic to know more about pointers. Output 50. Example program for size of open close bracket operator in C. Size of open close bracket operator is used to find the memory space allocated for each C data types. Output. Storage size for int data type 4. Storage size for char data type 1. Storage size for float data type 4. Storage size for double data type 8. Constants and literals. Constants. Like a variable, a constant is a data storage location used by the user's program. Unlike a variable, the value stored in a constant can't be changed during program execution. C has two types of constants, each with its own specific uses. Are the examples for literal constant. Symbolic constants. A symbolic constant is a constant that is represented by a name, open bracket, symbol, close bracket in the program. Like a literal constant, a symbolic constant can't change. Whenever the user needs the constant's value in the program, he can use its name as would use a variable name. The actual value of the symbolic constant needs to be entered only once, when it is first defined. Symbolic constants have two significant advantages over literal constants. Suppose that the user is writing a program that performs a variety of geometrical calculations. The program frequently needs the value of pi, open bracket, pi, close bracket, minus 3.14159 for its calculations. The value of pi is constant. For example, to calculate the area of a circle with a known radius, the user would write the following code. The asterisk is C's multiplication operator. Thus, the first of these statements means multiply 2 times the value stored in the variable radius and then multiply the result by 3.14159. Finally, assign the result to the variable name area. If, however, the user define a symbolic constant with the name pi, open bracket, n, close bracket, and the value 3.14, he would write the following code. The second advantage of symbolic constants become apparent when the users need to change a constant. Continuing with the preceding example, the user might decide that for greater accuracy, the program needs to use a value of pi with more decimal places. If the user had used literal constants for pi, he would have to go through the source code and change each occurrence of the value from 3.14 to 3.14159. With a symbolic constant, he needs to make a change only in the place where the constant is defined. The rest of code would not need to be changed. Defining symbolic constants. C has two methods for defining a symbolic constant. The first way to define a symbolic constant is the hash define directive is used as follows. This creates a constant named constname in capital with the value of literal. Literal represents a literal constant as described earlier. Constname in capital follows the same rules described earlier for variable names. By convention, the names of symbolic constants are uppercase. This makes them easy to distinguish from variable names, which by convention are lowercase. For the example, the required hash define directive for a constant called pi would be, note that hash define lines don't end with a semicolon. Hash define statements can be placed anywhere in your source code, but the defined constant is in effect only for the portions of the source code that follow the hash define directive. Most commonly, programmers group all hash define statements together near beginning of the file and before the start of the main function. How a hash define works? The precise action of the hash define directive is to instruct the compiler as follows. In the source code, replace const name with literal. The effect is exactly the same as if the user had used the editor to go through the source code and make the changes manually. For example, in the following code, the instances of pi in the second and third lines would not get changed. Note that hash define lines don't end with a semicolon. Hash defines can be placed anywhere in the source code, but they are in effect only for the portions of the source code that follows the hash define directive. Defining constants with the const keyword. The second way to define a symbolic constant is with the const keyword. Const is a modifier that can be applied to any variable declaration. A variable declared to be constant can't be modified during program execution, only initialized at the time of declaration. Literals. The constants refer to fixed values that the program may not alter during its execution. These fixed values are also called literals. Constants can be of any of the basic data types like an integer constant, a floating constant, a character constant, or a string literal. There are also enumeration constants as well. Integer literals. An integer literal can be a decimal, octal, or hexadecimal constant. A prefix specifies the base or radix. 0 small x or 0 capital X, ox for hexadecimal. 0 for octal and nothing for decimal. An integer literal can also have a suffix that is a combination of U and L for unsigned and long respectively. The suffix can be uppercase or lowercase and can be in any order. Floating point literals. A floating point literal has an integer part, a decimal point, a fractional part, and an exponent part. The user can represent floating point literals either in decimal form or exponential form. While representing using decimal form, the user must include the decimal point, the exponent, or both, and while representing using exponential form, he must include the integer part, the fractional part, or both. The signed exponent is introduced by small e or capital E. Character literals. Character literals are enclosed in single quotes, example, open quote, x, close quote, and can be stored in a simple variable of char type. A character literal can be a plain character, example x, an escape sequence, example, open quote, backslash, small t, close quote, close bracket, or a universal character, example, open quote, backslash, u, 02, c, 0, close bracket. There are certain characters in C, when they are preceded by a backslash, they will have special meaning and they are used to represent like new line, open bracket, backslash n, close bracket, or tab, open bracket, backslash t, close bracket. Here, the user have a list of some of such escape sequence codes. String literals. String literals or constants are enclosed in double quotes. A string contains characters that are similar to character literals, plain characters, escape sequences, and universal characters. The users can break a long line into multiple lines using string literals and separating those using white spaces. Simple assignments statement. A statement is a complete direction instructing the computer to carry out some task. In C, statements are usually written one per line, although some statements span multiple lines. C statements always end with a semicolon, except for hash define and hash include. Statements and white space. The term white space refers to spaces, tabs, and blank lines in the user source code. The C compiler isn't sensitive to white space. When the compiler reads a statement in the user's source code, it looks for the characters in the statement and for the terminating semicolon, but it ignores white space. This gives the user a great deal of flexibility in formatting the source code. Statements should be entered one per line with a standardized scheme for spacing around variables and operators. Basic input-output statements. The basic input-output functions are get char, put char, gets, puts, scanf, and printf. The first two functions, get char and put char, are used to transfer single characters. The next function, gets and puts, are used to input and output strings. The last two functions, scanf and printf, permit the transfer of single characters, numerical values, and strings. Get char function. Get char open close bracket function is used to read one character at a time from the keyboard. Syntax ch is equal to get char open close bracket semicolon, where ch is a character variable. When this function is executed, the computer will wait for a key to be pressed and assigns the value to the variable when the enter key pressed. Put char function. Put char open close bracket function is used to display one character at a time on the monitor. The computer displays the value char of variable open quote ch close quote, that is capital M on the screen. Gets open close bracket function. Gets open close bracket function is used to read a string of characters including white spaces. Note that white spaces in a string cannot be read using scanf open close bracket with %s format specifier. When the function is executed, the computer waits for the string to be entered. Puts open close bracket function. Puts open close bracket is a function used to display strings on screen. Output: welcome to Wikipedia. Scanf open close bracket. Just as most programs need to output data to the screen, they also need to input data from the keyboard. The most flexible way the program can read numeric data from the keyboard is by using the scanf open close bracket library function. The scanf open close bracket function reads data from the keyboard according to a specified format and assigns the input data to one or more program variables. For example, the statement reads a decimal integer from the keyboard and assigns it to the integer variable. The percentage indicates that the conversion specification. The D represents the data type and indicates that the number should be read as an integer. The AND is C, unary operator, that gets the memory address of the variable following it. The user will read more about this operator and its associated operator asterisk in the section Pointers in the course. Likewise, the following statement reads a floating point value from the keyboard and assigns it to the variable rate. The F represents the data type and indicates that the number should be read as a float. Printf open close bracket. The printf open close bracket function, part of the standard C library, is perhaps the most versatile way for a program to display data on screen. Printing a text message on screen is simple. Call the printf open close bracket function, passing the desired message enclosed in double quotation marks. For example, to display an error that has occurred on screen in addition to text messages. However, he frequently needs to display the value of program variables. This is a little more complicated than displaying only a message. It accepts a string parameter called the format string, which specifies a method for rendering a number of other parameters, of which there typically may be arbitrarily many of a variety of types, into a string. For example, suppose the users want to display the value of the numeric variable x on screen along with some identifying text. The resulting screen display, assuming that the value of x is 12, would display the following. The value of x is 12. In this example, two arguments are passed to printf open close bracket. The first argument is enclosed in double quotation marks and is called the format string. The second argument is the name of the variable x containing the value to be printed. Simple C programs. The Hello World introduction. The best way to learn a computer language is to start writing short programs that work and then gradually add complexity. The traditional first C program prints out open quote hello, world, close quote and looks something like this. C programs. Example program of use of the gets open close bracket function. Output. Example program of 2 multiply 2 integers. Output. Example program of frequently used escape sequences. Output. Conclusion. In this chapter, we have covered the following aspects of introduction to C language: character set, variables and identifiers, built-in data types, variable definition, compilation, arithmetic operators and expressions, constants and literals, simple assignments statement, basic input-output statements, simple C programs.